Hello and welcome to this video as part of the coordinate geometry series, and in this particular video we're going to look at linear programming and how to model a linear programming using a series of linear inequalities. Now this whole series of videos is part of the OCR Additional Maths course, and the linear programming problems are often worth quite a lot of marks in the additional maths assessments, so it's really critical that you can model these correctly, as otherwise it will have quite a large impact on your ability to do the rest of the questions. Okay, so let's look at this problem. A school wishes to transport students and teachers totaling 300 people to a concert. It uses a coach firm that can provide minibuses which can seat 10 or coaches that can support 30. The coach company has 15 minibuses and 8 coaches. Let X be the number of minibuses and Y be the number of coaches that the school hires. Write an inequality in X and Y that must be met in order to transport the students and teachers. Didn't mean to do that, never mind. Right, so we're only interested in being able to transport students and teachers in this inequality. So what do we know about this? Well, if there's X minibuses and a minibus can seat 10, then 10x must be the number of people that are transported by minibus. And if 30 can go in a coach and there are Y coaches, then 30y is the number of people transported in that form. So 10x plus 30y represents the total number of people that are can be transported. And because there are 300 people that need to go, this must be greater than or equal to 300. Otherwise, some people are not going. So what we could then do is we could take this inequality and we could divide everything through by 10 to give us x plus 3y is greater than or equal to 30, just because we get slightly nicer numbers to deal with. So let's look at part 2. So this says write down 2 more inequalities regarding the maximum number of vehicles that can be hired. So the maximum number of vehicles can be hired, right? So there's only 15 minibuses and 8 coaches. So if x is the number of minibuses, then x must be less than or equal to 15, and y must be less than or equal to 8. So here we go. We have set up 2 more inequalities regarding the maximum number of vehicles. We've got there one for minibuses and we've got one for the coaches. So here are 3 sets of questions that you can have a go at. Each one is asking you to do some modelling. And then here are the answers. Where I've put the answers in brackets, that's just a simplified version of the inequality, just to reduce the numbers to the smallest integers we can use.